Welcome to Out of the Lab, a podcast interviewing entrepreneurs who've taken research out of the lab and built it into a company that's serving the world. These entrepreneurs are heroes, and the planet needs more of them. So tune in, learn from their successes and failures, and get inspired. Visit bountiful.work to join our community and realize your power to save the world. Hello and welcome to Out of the Lab. I'm your host, Max Finder. Today's guest is Ric Fulop. Ric is the chairman, CEO, and co-founder of Desktop Metal, a leader in mass production and turnkey additive manufacturing solutions. It's basically metal printers, and they do a ton of cool stuff. They were taken public recently on the New York Stock Exchange. He founded it in 2015 with some of the scions in advanced manufacturing, material science, and robotics, including the person who literally invented the first 3D printer and the concept of 3D printing. Before Desktop Metal, Ric was a general partner at Northbridge Venture Capital Fund, a very large one with $3 billion under management. He had led the software and 3D investing practices and was an early stage investor and board member in a bunch of companies, one of which was acquired by Oracle for $600 million. And he really understands 3D printing, additive manufacturing, a bunch of things that took him to found Desktop Metal. Part of that was because he founded A123 Systems before he became a VC and spent 10 years leading this company. A123 was Boston's largest IPO in the past decade and one of the world's largest automotive lithium-ion suppliers, with revenue exceeding $500 million in 2016. He has an MBA from MIT Sloan, which he got because he wanted to marry his wife. We talk about it a little bit on the episode. He is a former board member of the Electric Drive Transportation Association. He's really one of the best entrepreneurs of our time and gives a ton of advice on picking markets and figuring out how to decide what business, what area, what sector to get into. So it's a short episode, about 30 minutes. Ric is a really busy guy, but it's extremely valuable with tons of insight and advice for young entrepreneurs and grad students looking to build a physical sciences technology startup. So enjoy. Visit bountiful.work, WORK, to join our community and enjoy the episode. Thanks for listening. Ric, thanks for joining.
It's a pleasure, Max. Excited to be here with you and your audience.
Thank you. So can you before you're a prolific serial entrepreneur, and before you even started A123, which I know is, one of the major companies you're known for, along with Desktop Metal, which you're currently running. Before A123, you had several companies that you had started. Even one was potentially, I think, acquired by Microsoft. Can you tell us a little bit about your early entrepreneurship journey before you dove into A123 Systems?
Absolutely. So I grew up in South America, in Venezuela, and then came to school in the States, and was involved in a couple of small companies, startups that didn't go to very large size, but all technology related. And I worked on parametric modeling in the early days of parametric modeling in the early 90s. I started one of the first virtualization software companies. That's a technology that's now part of Windows. It was a small acquisition. Nothing that got to real scale until I did A123 in my 20s. I was one of the co-founders of the company with an MIT professor and a couple of folks.
And how did A123 get started? It was originally a license that you took from MIT, correct?
Well, I had an idea to do something in energy storage, and I was doing research for about a year, looking for technologies to start, and knocked on professor's door at MIT, Yatming Chang, and we hit it off, and we sort of set out to do 3D self-organizing batteries, and that's the original technology we licensed from MIT. Although that technology didn't get too far, very quickly we realized that that wasn't going to work, and we sort of pivoted to lithium iron phosphate, which was a technology that at the time didn't have power density, but we found a way to increase the conductivity by eight orders of magnitude by doping it with niobium, and we developed that into a reasonable sized business over a period of a decade while I was there. So I was there from 2001 through 2010. By then we had taken the company public, over 1,600 employees, a couple $100 million revenue. And I left the business because I felt like battery prices were going to decrease dramatically in the decade that followed, which they did. I mean, at the time that I left, cost per watt hour was about $1, and today is probably 8 cents, so or less. So, over 90% decrease in price. So it's kind of a hard slide, but I felt like we should sell it. My partner wanted to keep running at it. So, a few years later, they ended up going through restructuring and selling the business to a company called Wansheng, which is a major automotive supplier in China, but they still are around today and are a major supplier to many vehicle OEMs. So any low voltage hybrid probably has, or most of them have A123 batteries still.
And I know it's a while ago, but if we go back to those early days when you were knocking on doors at MIT, were you doing an MBA at the time, or this is even prior to that?
Prior to that. So I went to grad school later. So the early days of A123 was physical science, material science discovery, and work to make this chemistry work. And I was trying to get married, and I was dating my wife. Her parents were professors at Harvard, and they wouldn't let me marry her without going to grad school. So eventually, I had to go to school for them to grad school for them to let me marry her. So I got into MIT for an MBA, and at that time, A123 was still a pretty small company, under 40 employees. And so I said, okay, I think I can manage this, and would take very early classes and late classes on the electives, and try to do as much work during the middle of the day. My partners were pretty supportive, but by the second year, we had an inflection, and by the time I graduated, we had 400 employees. So it was kind of a really crazy second year in grad school, and they put up with me. But then I was back full time, 2006, and we had a period of hyper growth from 2006 through 2010, including going public.
Yeah, it's an amazing story, and you must have been one hell of an MBA student at that time, potentially able to teach some of the classes, I think. But I'm really curious as to why the Oh, sorry, go ahead.
I mean, it's a pretty exciting thing. I mean, it tells you how long it takes for some technologies to really take hold. If you look at the Model 3 from Tesla in China, it uses the chemistry that we had invented at that time, and still the only chemistry that doesn't have any cobalt, and that would scale to sort of the adoption level of very, very high throughput lithium ion adoption. If everybody goes electric, there's not enough cobalt and nickel to support demand, so they would have to go to an iron-based chemistry. That'll happen over time. But it's great that the technology we invented is now being used at scale, and it's used at scale in low voltage hybrids and a number of other products.
And would you say you were ahead of your time with this company?
I wouldn't say we were ahead of our time. That's like saying Intel was ahead of their time in the 70s. I mean,
right.
We were doing something before EVs had truly taken off. It was primarily used in low voltage hybrids and plug-in hybrids. Over time, as EVs took off, that technology continued to improve. But it is, I mean, we were doing it when nobody else was doing it, which is kind of the marker of whether you're really doing something innovative. If everybody's trying to do something at the same time, it's usually, less exciting, I think.
And what I love is that you spent a year looking for technologies. Like, you really wanted to start a deep technology company. I mean, were you looking at other, like, if you can remember, were you looking
Sure.
at other things beyond batteries?
No, I spent a year looking at energy. So it's
At
not
energy
hard.
storage. Yeah.
Yeah, you're trying to find, usually the scientists aren't, the chance that you have success with a scientist trying to commercialize a particular technology is relatively low. Much higher likelihood that you understand the business problem, and then you go around the world and try to find the right technology to solve that business problem. So that's more of my approach. And in my point of view, we looked at a lot of things, and believe it or not, we didn't pick the right one at that time. The technology we picked didn't really have the right. It was too difficult to manufacture, and so we ended up going to something simpler, which was still built into a reasonable sized company at that time. I mean, this is 20 years ago, so
right.
a long time ago.
And that's the nature of successful startup teams, right? Is your ability to adapt, and it's more about the team.
You fail fast, and then you kind of use the resources you've got to figure out what you're doing, and you try different things. And I mean, this is a long time ago.
But you were still sort of a semi-successful entrepreneur at the time of knocking on this professor's door. Like, why was he taking you seriously, and what advice would you give to other, would-be entrepreneurs that consider knocking on professors' doors and looking for opportunities?
I mean, I just think don't focus on it's not hard. All professors want to commercialize their stuff. That's not the hard part. The hard part is finding a problem that's worth solving and then matching it with the proper technology. The technology is out there. It's the understanding what the market wants and usually you can't buy research to do this. This is something that is, this is something that is completely a skill set.
Right. And what are some of the characteristics of that skill set? Like, and do you think it's something that people can sharpen?
No, some people are good at it. Some people suck.
It's just innate. It's this ability to sense whether there's an opportunity or not.
Look, you gotta find people. Like this is like working for a record company and being able to spot hits.
Right. It's just, you feel it.
Yeah, I mean, some people have a good sense for a market. I mean, if you know how to spot problems or opportunities, and you're in an industry, you can move from industry to industry to industry and continue to over time find opportunities. It happens all the time in venture capital. Some venture capitalists are really good and some aren't, and it really is about being able to spot talent and spot problems and come up with a market, understand that a market's going to be big, and that you're making when the investors that invested in DM did so 6 years ago, additive was not a hot sector at that time, and they did it based on a point of view. And if you're right on that point of view multiple times, you can make a lot of money in venture, for example. So I think that's and having been a venture capitalist myself, after A123, I did venture investing for 5 years and, deployed about $130 million that today is worth, in the range of $1 billion. So I think we did quite well. But that, I would say is a skill set that you hone in. So,
yeah. How was that transition from A123 to venture capital? Was it natural for you because it's the same thing, being able to spot a market?
Venture capital is a much slower pace than operating, and it's actually kind of boring. It takes a little bit to get used to it and to get the right investment pace, but it's like breakfast, coffee, lunch, coffee, dinner, and you're hearing a different pitch every couple hours. And after you do that for some time, you get good at figuring out who's going to be good at it, who to back in terms of someone you can back versus the average person. So I think I enjoyed it. You don't really know if you're good at it for another 6 or 7 years or 8 years after you you are a VC, because that's how long it takes for the first companies to really get liquidity. But we're pretty good at, we put the money to start Dyn. That company we sold, we owned a third of it. We sold it to Oracle for $600 million. That deal returned about over 200 million. We were the original investor in Mark Forge. I think our seed round was like $1 million at 2.5 million pre, and they just went public and are worth a couple billion. So our shares there are significant, and so on and so forth. So there are a number of stories like this. Not everything you do work. We're the original investors in Salsify, which is now a company that's worth over $1 billion. We were the original investors in a company called Gridco, which was a grid-related technology that was fantastic, but the dynamics of the market adoption in grid are difficult. So that particular investment didn't work out. But you try different things. Onshape's another company that was quite successful. We put the money to start that, the first $9 million to get it going, and a couple of years later sold it for over $500 million to PTC. So you build a niche in an area. My niche was 3D in manufacturing technologies and related software, and that worked out quite well.
And so the day-to-day of coffee pitch, coffee meeting, lunch, whatever, I mean, how does that contrast, I guess, to your day-to-day as an operator?
Well, in an operator, you have a lot more things going on. In venture capital, you don't have to work very hard to do very well. In venture, you have to. Being an operator, you have to. That's the opposite. In venture, you don't have to work that hard. In operating a company, the pace is dramatic, like 100 times more stuff going on, and you got to work much harder to build. You got customers, you got suppliers, you've got people. It's a much more complex type of business. So, I apologize for the dog in the background.
No problem.
You wanna?
You're an operator. It's you have employees to deal with.
Well, the dogs come to the office in our office, and so we have our puppy in the background, but I'm in the office.
Yeah. And so then you transitioned out of venture again back into building another company, which you're running now, Desktop Metal. I mean, what was that transition like? You discovered a problem that you just had to solve. There was no other way. In 2012,
I wrote a thesis about investing in the next generation of additive. Additive had been very strong for producing prototypes, and we were a heavy user of that technology at A123, so I was very familiar with it. I was also very familiar with powder metallurgy, since battery electrodes are essentially built through a PM process. And I in the thesis, I had a few different sectors. I thought that somebody should do elastomer parts, which didn't really exist in additive yet. Somebody should do high-speed metal printing, inaccessible metal printing, which didn't exist at the time. Somebody should do continuous carbon fiber, and so on and so forth. I ended up, somebody should do cloud CAD. We ended up funding Onshape on the cloud CAD side. We funded Mark Forge on the continuous carbon fiber side. I kept looking for opportunities in metal. I didn't see anything that I liked over several years. So eventually I said, you know what, we should try to develop a powder metallurgy route to printing or other inkjet related approaches. Those were the things that were going through my head at the time. And that's how I ended up here. So I put a team of people together.
So you developed this thesis, and then the next step is, okay, I got to hire some experts.
No, the thesis was in 2012, and
I'm sorry, but you're working on this thesis and continuing to find.
I didn't start PM until 2015, but for several years I was looking for startups to put money into, for example,
right, in this area.
Onshape and Mark Forge are two examples of it, and obviously we missed Carbon and a few others. But you don't get everything. But I eventually was successful at getting a couple of deals up and running, and then I was frustrated. I wasn't seeing anything in metal, and I was bored being a VC. It was I didn't like the pace. I was more of an operator. And so decided to start DM in 2015.
Right. And so when you make that decision, I guess I'm curious about the next step. I mean, it's like, okay, we need to, you had an idea of who you needed to bring on board as far as developing the technology further. And that was the first step, or was it raising money?
No, we didn't build anything with university technology, although I wanted to have access to great people that could help us reduce to practice lots of different ideas that we had in our heads at the time. So I put a team that included Jonah Meyerberg, who ran our Formula One team at A123, is somebody I've collaborated with over the years. And then 4 MIT professors that included Yet Chang, who was my co-founder in my previous company. He's the top ceramist at MIT. Included John Hart, who is the top 3D printing prof at MIT and had been a classmate. It was at MIT at the same time as me, and a long friend. It included Chris Chu, who was the chairman of the material science department at MIT, a really fantastic metallurgist, and also included Ellie Sachs, who is the actual inventor of the 3D printer, coined the term and invented the binder jetting process, and was doing this in the 80s and the early days of 3D. So he's been a fantastic partner, and we set out to try a few different things, and eventually we found what we thought would be a great killer first set of products, and have continued to evolve the company ever since.
And are they're operating as part of their like university allowable 20% of their time for private, for private stuff, for private consulting and things like that? Is that the context? Yeah.
I mean, I would say Ellie was full-time with us. He's a professor emeritus. And then the other folks were within the 20%. But I think contributing a concept or an idea is sometimes priceless, right? So understanding how to do something that no one's ever done, or coming up with creative ideas to do that, is what innovation in physical sciences is all about. So really, you want to have spectacular people around you. And then we were able to tap access to graduate students as they came out, and resources and things like that. So we built a great, it was, I think we were really happy with the partnership that we had over the years.
They have equity in the company. I mean, that's like a kind of the standard for.
Yeah, the American system, you've got people work for equity early on in the early days, and you raise venture capital to fund high risk work, and so that's the way that it traditionally works in a setup like this.
And what I want to now ask you about is how, so at that stage, I mean, it's you, some MIT professors, and you start to hire kind of some grad students.
We hired like 10 people in our first day. So
your first day.
Yeah, my last company had 1,600 people when I left. It wasn't hard to we kind of put the band back to recruit people, get scale quickly on folks that knew how to do stuff.
Right. And you pick up the phone and people are like, yeah, I'm in. It's the band getting back together.
Because we had put in large enough, so I think it wasn't hard to get traction quickly and get to some scale that would allow us to execute.
Is this something you capitalize yourself at the early days to kind of get to some type of prototype or MVP, or?
Yeah, obviously, nothing good happens while you wait in technology. So it's a competitive market. So you don't want to spend 3 years developing a product.
Right. And so from those very early days, I mean, what I think is cool is how you're able to kind of evolve with these companies as they grow. So it must be a completely different environment as 10 people, and now as 400 or however many people you have now at DM.
We're about 550 people today.
Right. And so things have obviously grown quite quickly. Is it you as the entrepreneur and the person running the company, is that different? I mean, what are some of the skills and things to be aware of? And
The key in a physical sciences business like this is to have small groups with high accountability, because you're trying to, in physical sciences, you fight with nature when you develop a new process. So you want to have sorry, I apologize for the noise.
No problem.
You want to have a team that's highly dedicated and that can do spins very quickly.
Got it. And are there any other kind of pieces of culture that, you really are very insistent on, things that really kind of build your company together? High accountability, small teams. I really like that. Anything else like that that's worth mentioning?
I mean, I would say that we're a pretty progressive company in terms of the types of people we bring on board, and we're really open to new ideas, new ways to do things, and we're not very bureaucratic, right? I hope we stay this way.
Right.
And, it's okay to try something and for it not to work. That is our culture. You try a lot of things until you figure out a way to do something. And at least I'm describing now the technical effort, and the technical side of the business. We've invented a lot of things, and have been successful at developing technologies that nobody had before. So we did that by basically dedication, and sometimes you can't make something work, but we've been very successful at developing new technology as a result.
And are there lessons that you took from A123 that you've brought to Desktop Metal? I mean, are there things?
Absolutely. Look, lessons learned, and you learn all the time as an entrepreneur, and I think the key is for startups to be successful, you cannot have account concentration. One of the issues with batteries or water or power or some of these big hairy type of science-driven companies is that they have account concentration. You can't get into the business in an organic growth mode. You need to build a giant plant, or you need to do this. Those are very, very difficult things to make work in venture. And we pulled it off at A123 during the time I was there, but it is much harder than what we do at DM. What I love about DM is we have no account concentration, and we have a diversified business. No customer accounts for more than 5% of our revenue. We have a business that allows us to have pricing power and much better margins, and with a consumable revenue stream. So it's I like recurring revenue, and I like low account concentration, and that's what we've focused on building at Desktop Metal versus my past life. It's sort of like you learn something in the past, and then you realize, okay, I'm going to do something different this time. And, those are two of the things that I've focused on: high margin, recurring revenue, and low account concentration.
And if you had to think biggest avoidable mistake or lesson learned or something, it's about account concentration. Is there anything else that comes to mind?
I'm just sharing patterns. I mean, you could, there's always going to be somebody that pulls something off in a particular market, right? So there's exceptions to these rules in entrepreneurship, because there's outstanding people out there that can walk through walls. However, as a general rule of thumb, it's more difficult to have venture financing for a company that has high account concentration, and so I focused on building a business model and setting up the company in a way that we can do disruption from the bottom, which usually has low account concentration, and being able to do it in a way that's more organic, where we don't depend on a few people to be successful.
If you had to talk to the young Ric Fulop embarking on his entrepreneurial career, what would you say?
I would have just said what I just told you
about account concentration.
Try to focus on a startup that has high margin, recurring revenues, low account concentration, where you can have differentiated technology, and another thing that is as a business, there's two types of phases for where technology gets adopted. It's a lady named Carlota Perez that is at London School of Economics, and she writes about Gilded Ages, and her work usually talks about two setups. One is sort of the inception phase, and the other one is the installation phase of a technology. And they're usually gated by these are usually gated by two 20-year periods. In the first one, you've got one major invention with a lot of IP protection, and then not a lot of competitors, and really it's like a IP driven. This thing kind of lasts for 20 years, and that IP structure sets you up with high prices, relatively moderate adoption, but not massive. And then when the IP expires, those companies get clobbered. An example where you are in Israel would be Stratasys, which started with FDM, that had its 20-year run, and now they're being massacred by all this FDM clone technology that is everywhere. You can buy a Prusa for $1,000 and do similar stuff as what their printers 7-8 years ago did for $100,000. So the second phase is usually where we're going into additive today, which is the installation phase, where it becomes a mass market, broadly used technology. And that's the second 20 years. It's usually a much bigger opportunity in the second 20 years. And the winners usually are new companies that sort of build on the shoulders of giants and innovate and develop IP and either new distribution models or new technology on top of that, doing things differently with a different production or cost structure or new approach to it. And that pattern repeats of installation deployment repeats itself in history over and over and over in many industries. And so I think it's and there's usually a crash in the middle in between installation and deployment. We saw it in 3D printing in between 2014 and 2017. That's like the best time to start a company, because in our particular case, the incumbents, the 3D Systems and Stratasys of the world, were cutting R&D budgets, laying people off, and shrinking from a developmental point of view. And here we were on the private market with venture money doing innovative things and developing new technology. So that affords an umbrella to a startup that allows it to develop new technology and not get clobbered right away by some of the large incumbents. So I think that type of setup where is really conducive to new entrants being developed. That transition from installation to deployment phase, and we timed that right on this particular company. So I'm kind of happy about that.
Excellent. Well, I want to be respectful of your time, Ric. Any last pieces of wisdom that you want to throw to the grad students and entrepreneurs in our audience? You've given a lot of. Yeah, go ahead.
Yeah, I would say that just in our particular case, we're as that deployment phase scales in additive, we're going from 12 billion to 146 billion. It's usually that hyper growth phase that's great to build a startup. Try to find an industry that don't get enamored with a particular technology. Get enamored with solving a business problem, and then it doesn't matter if you invented it or if somebody else has the solution. It's the implementation to solve customer problems and being in the right dynamics of a market where you don't have account concentration. You can build something that has pricing power, and where if possible have recurring high margin revenues. That's a great setup for a successful physical sciences business.
Perfect. Ric, where can people find you?
On the internet.
Just Ric Fulop on Twitter or something. Is that what you prefer? If they want to ask
that, or on DM.
At DM.
Yeah, I'm usually a Desktop Metal. I'm usually pretty accessible.
Okay, Ric, thank you for joining. Visit bountiful.work for more. And I appreciate you being with us today, Ric. Thank you.
And Max, good luck to you again with your project to help people start more companies in physical sciences, and good luck to all the entrepreneurs that are gearing up to commercialize technology. It's a wonderful thing to create value for society this way.
Thanks, Ric. Thanks for listening. But now we need your help.
We're building a community of scientists, students, entrepreneurs, industry leaders, and investors to commercialize meaningful technology and research. Join us at bountiful.work today to find opportunities and realize your power to save the world.